I'm co-founder of Powered 4 TV. So we're a wrestling video streaming service, which we've written in Blazor WebAssembly. So we've been running .NET 6 preview builds ever since, I think, preview 2. You might have seen Scott Hunter mention us in the keynote speech, so that's pretty awesome. So we've got a few learnings that we've made along the way. So just share a few of those on making a production-ready app. So the first question is, what does production-ready actually mean? For me, it's a bit of a checklist for, like, can we put this app in front of our customers and can we support it? Do we have like appropriate logging and telemetry? Are we able to respond to bug reports? Are we giving a good experience for customers? Does the app work? Is it crawlable by search engines? So on. So we're just going to focus in on a couple of areas of that today. So more around customer experience. So we'll have a quick look at pre-rendering an app, which is good experience for customers and SEO. Maybe we'll have time to look at reducing download sizes a little bit. And we'll try and have a bit of a look at writing maintainable code as well that hopefully means that we can support it and keep adding awesome features. And we'll be doing that with BUnit, which might segue nicely into the next section. So to not waste any more time, we'll just jump into a demo and some code. So if I can get rid of that. I've built this small app just for demo purposes called Blazor Beast. The app doesn't really matter too much, but it's just a little target shooting game written in Blazor with a little menu. You can go into settings, you can resume. It's got a timer that counts down. We get a score. And then at the end of the time, we'll get game over and our score. And that's it. And that's not doing anything fancy, just a few CSS animations and a few components. We've got some scores here, which is calling from an API. You'll notice that it's a little bit slow. That's purposefully a little bit slow. But this is just hard-coded at the moment, but just to demonstrate making an API call. And a couple of other pages. There's some licensing and things, so awesome. One thing at the moment that's annoying about this app, that when you load it, we have this loading screen. So I'll just do it again, but you'll notice there's a flash where we've got loading, and then it opens up. So I think, first of all, let's try and get rid of that. So I'm just going to, try and sort my windows out a little bit. So we've got a few projects here. So we've got a client project and a server project. Our client project, a lot of Blazor WASM apps or WebAssembly will have an index HTML, but I've already gone ahead and serving my app from a page in here. So we are setting the component type of app, and that's coming from the client. And as you can see, the render mode is currently WebAssembly. And I'm just going to go ahead and change that to pre-rendered. And I'm going to remove this loading because we won't need it. And I'm also in the layout. We've got another component here, which gives us the head and the title and any meta tags. I'm going to change that to pre-rendered as well. Just a quick bit of maintenance. I'm going to remove this. Remove this line of code here, which was just replacing the loading. So I'm just going to run that again. We've got hot reload, but I've made a few changes that require a reload. So we'll just give that a moment to run. Oops. While I do some window management. It's just running slightly slower, I think, because I'm sharing my screen. But that should run. And we've got an error. Actually, why is that? So the important thing when pre-rendering to be aware of is that your dependencies are registered independently between the client and the server. So here, this is our program CS for the client, and you'll see we've got this HTTP client, and we've got this timer factory. Those are not on the server, so we need to add those in. So this is cool. It's a bit of a weird one at first, I found anyway, but it's actually good because we have no fear that registering anything on the server, that's not just going to be pulled down automatically in the client. So let's just run that and try that again, and you'll see it's come in. So if I just run this now, that's just instant. You don't even notice it. And just to prove that it's being pre-rendered, we can have a quick look at the dev tools. I'm going to go to the network tab and the dock, hit enter, and we'll see that that response is being pulled down with lots of lovely HTML. So that's great. Then we'll just check that all the pages are working. So the scores is working, and then I'll load this from the server. And you might notice that although we've pre-rendered the scores, we have a flash of loading again. So to make that loading flash more pronounced, I've made the API call a little bit slow. So again, we can just have a quick look and see that this document is coming down, but then the app, when it initializes, doesn't know about this. So it's going ahead and making the API call again, and that is causing that flash. So we can fix that. So if I come back to our code for a moment, we'll find the page that's important, which is our high scores page. And you'll see that we're rendering this high scores table. If we just have a quick look at what that's doing, it's nothing fancy. We're just making an HTTP call. And if I just go back one, I've re-implemented this component with persisted state. So persisted state is how we're going to stop that flash. And what will happen is we'll make the API call on the server, but then we'll actually render the state as an HTML comment in the page, which it will then read that and hydrate the state. So now when we load the application on the client, it's going to try and call from application state to get that using a key of our choosing. And it's going to load, it's going to set that. Else, we're going to make our API call as we were before. And just how does the application state work? Well, we register a callback, and so the server will call this method to persist the high scores. We also need to do just one more small bit of maintenance in our host page here and add in a new component called persist component state. Save that, we'll reload, and I've done a rude exit apparently. We'll just wait for that to reload and run. There we go. So now if we come back to our Blazor Beast app, we'll go to the scores page. So that loading was because I navigated on the page, but now hopefully when I go to the page first, we no longer have that loading flash. So that's pretty cool. That's already filling a nice experience for our customers. What I don't like at the moment is because we do have that moment of loading. Like if I refresh this page really quickly and enter this play button, it doesn't work. It doesn't work during that period while the app is initializing. But now when I hit play and it has initialized, we can go back into the game. So I would quite like to show a loading here just to stop frustrations from customers. I'd like to show a loading here until it's loaded. And if you think that, like on this laptop, it's just like really quick, but on a, I don't know, 4 or 5 year old phone, maybe a mid-ranged phone, it might be slightly more longer, just longer. um, okay, so let's have a look. So the first thing I'd like to do is know whether I'm rendering on the server or rendering on the client, where the client is running in the web browser. And this, so I've created a new type called render location, and I'm going to set that to rendered on client. So if we just have a look at that quickly, it's just a record for render location, and then I've got two options of render on server, render on client, and that's going to be how we know. And where I talked about the dependency injection being separate on the client and the server, this becomes useful because we can register render on the client, and we can register on the server, rendered on server. Let's just fix that reference. Now, I don't want to just make my changes and then hope that they work, and maybe I want the confidence to be able to refactor my code later. So I want and make sure that I don't enter any regressions. So I've actually got some tests which I'm going to run now and make sure that they pass. And what I'd like to do is implement this small change, but we'll use bunit, which is a unit testing library that you can use with your favorite test runner like XUnit or NUnit, as I'm using here. So all of our tests are currently passing. And we've got this main screen. And these are the tests, but let me just open up this main screen. I'll do a little bit of window management and pull this over. So we've just got a basic menu, which just has a single button with a play button, which on click is going to perform the action that's passed to it as a parameter. So at the moment, I've got a test where we display this button when rendered on the client. So I'm just going to add in this, this little bit of test setup to set our render location on the client. And this render method here is the bunit exciting thing that's very powerful. And then we've got the main screen should perform the play action when the play game button is pressed. So I'm just going to do the same thing here and have that set up. So those two tests pass, and we know that. So they're good to make sure that we don't enter any problems, like we don't introduce any regressions whilst we make this change. The next test I'm going to have is that the main screen should not display the play game button when rendered on the server. So here we are rendering the component, and we'll just make sure that when we try and find the play button, that an exception is thrown because it doesn't exist. So I'm just going to come over here and inject the render location. And add in a little if statement here. Oops, sorry. Render location is rendered on the client, we'll have the play button, else we won't. So I'm just going to rerun these tests. Oh, just be a moment. Hopefully. There we go. And that passes. In true TDD style, I should have made sure that it failed first. I'll do on this one. So in this one, we're saying the main screen should display loading when rendered on server. So I'm just going to run these tests again. Hopefully they'll run a bit faster this time. That should fail. So I can add in my loading component here. Save that. We'll run, make the test pass. And while that's running, hopefully that will pass in a second, but we'll start looking at the next one as everything seems to be running a little bit slower. And then my final test will be, look, we do not want to display the loading when rendered on client. So I'm not going to run it beforehand this time, just in the interest of saving a few moments of time. But at the moment, this test will fail because we are rendering it, whether it's on the client or not. So I'm just going to drop an else around here, pop that loading in, and now that test will pass. So I'll just do a final run of the tests. And oops, they should pass. And we can just quickly run the app to make sure that that's working. There we go. So now we see there's the loading, and then as the app initializes, it goes back to the play. So that will stop our annoyance of customers. One other thing for supporting the app that we can try and do quickly is it would be nice to know what version of the app is running. So where we might have this as, for example, like a progressive web app where people might have installed, they might, so we can run the app. It might be, I haven't here, but it could be set up to run offline, or we might just be releasing new versions or split testing. For our logs and telemetry and any bug reports, it'd be nice to see the version. So we will just quickly add that in. So I will just come over into my client and the app here. I'm going to add in a parameter of string. Sorry, let me close these windows. Parameter of string, and I'm just going to call that version. And I'm going to pass the version into this, but I want everything inside of my app to know what version it is. So I'm going to create a new app version and pass that version into it. Now this property will be available to everything. This app version is just something, it's just something that I've written, but we'll be able to use that. So if I save that, and I want my version to be in the footer. So I'm going to go into shared, and I've got a footer in here. And I will add a new code block. I'm going to add in a cascading parameter of type app version. So it will find the version, or it'll find the cascading parameter matching by type. And I'm going to drop that version. I'll just pop it. App version. Version. And with hot reload runs. Oops. Oh, I stopped it running. Did I? Let's reload that. We should hopefully see, well, we've got an unknown version. So we just need to pass the version to it. So I'm going to get that from my server. So in my host, I'm going to add in a new var version equals, and I've just created a little extension method that will help. So we'll get the version of the actual DLL from the entry point. So from here, and I'm going to pass that in as param version equals, and I think I did a string, so I'll pass this in as a string. And then this should hot reload. And then we'll see that we've got the version 1.0000. So if you're setting a version in your CI/CD pipeline, you can use that, and then we can pass that through into anything else. Cool. One other thing when we're thinking about sizes of the app. So I just did a quick check and I published this app with a release, and the overall size of it was about 1.8 megabytes in size. So, it's a bit big for a web app. And if you want a really small app, maybe Blazor Server might be better for you. But we can still make it a little bit better, save a bit of space, and improve loading. So there's a few ways we can do that. So there are a couple of feature flags that we can use to optimize some space a little bit. So there's Blazor enable time zone support and invariant globalization. So you can disable this, disable the time zone support and turn on invariant globalization if you don't really care too much about those localizations, which my app doesn't. So we can have a quick look. It takes a little bit of time to build and run, but just by Blazor enabling the time zone support to false, we save approximately 43.6 kilobytes. So that's okay. We can save a bit more by the invariant globalization. That saves about 175 kilobytes in this app, mostly by not needing this data file. And one final thing is there's the new Blazor WASM tool Workload. So I think Dan Roth has talked about this and showed it off, but that will link your the WebAssembly files. So it'll actually remove anything that's not used and needed from the WebAssembly, and that has saved 498 kilobytes in that, and it's also saved a little bit of the JavaScript, so saving us about half a meg. So just those few optimizations in this particular app, it saved about 729 kilobytes. So it's coming up to half the size. So that's pretty cool. And then maybe the final thing, we could lazy load some DLLs, but I think we won't look at that for the moment. The final thing we can look at is the scores API. What would happen if this API errors? So I would like to just go back to my page and the high scores page. And we'll go to here, and I've got a separate API endpoint that will throw an error rather than just being a little bit slow. Save and reload that. So now if I go home and then back to scores, you'll see that we get an unhandled exception in the dev, and it's a bit of a nasty error message down there. If I render it from the server, even worse, we're getting a 500 internal server error. So that's not cool. So we can do better than that. And there's a new component in .NET 6, which will help us. So if I go back to the high scores page, I can wrap this component in an error boundary. Save that. And then we'll see that now we get this nice error. I say nice, it's a little bit ugly, but we get this error boundary, but we're not getting a 500 internal server error, and we get it for there. So that works for both the client and the server. If I go back to my code, we can do one better. So that's a bit ugly, but we can instead move this into child content. And then we can have an error content. So then we can more easily change. So we could put a component in here. I'm just going to put a paragraph with a class of alert, danger, like, oh no, please try again later or something. I can't type. Save that. And then now, hopefully, when we get the error, oh, did it not? Did I do it wrong? Oh yeah, here we go. So we've got my new, it just took a moment. So we've got my new, so we could put any component in there and it works on the server side. So it's just thinking about some of those error scenarios as well for production ready, rather than your app and site just falling over. Cool. I think that's probably about it for the time. I don't know if there was any questions, or I can show you some more, but I might go over them.
Yeah. Hey, Steve, thank you for showing us those insights. I don't see any questions here as of now. So I think let's wrap it up.
Awesome. Cool.
All right.
Thank you very much.
Thank you, Steve. Thanks so much.
Have a good day.
All right. Take care.
Bye.